Hello, my name is Andreas and I'm the author of JWildfire and now JWildfireSwan. This is the first video in a series to show and explain you the new software. There are about 10 videos from beginner to advanced level planned for now, but you are welcome to write ideas for other videos in the comments. So, what is JWildfireSwan, or Swan for short? Swan is a powerful editor, animator, and renderer for flame fractals. It's very similar to JWildfire in that way, but it is not really a successor to JWildfire in a way that it shall replace it. It may look this way, maybe because JWildfire had not received any updates for a longer time, but this is only because I had a clear focus on the new software. In fact, I had planned a tight integration between both software packages from the beginning. Because of this, Swan uses the same model for flames, for example attributes, and the same file format, even if this is not optimal in some ways. So you can use most of your flames in both packages. For example, designing a flame in JWildfire when you prefer the way of editing you are familiar with, and then animate it with Swan, or vice versa. So what's the different focus of Swan, or why Swan at all? This is a longer story. As long as JWildfire exists, GPU rendering was a topic. In the first years, there was no GPU rendering at all in JWildfire, but users had always a large demand for it. So it was discussed quite often. We had even a Kickstarter campaign, some of you may remember. But the software architecture of JWildfire and the technology used makes it very difficult to implement GPU rendering. And even if we could success with this, it would be a large effort to keep it up to date. This influence is often underestimated in software development, I guess. Keeping things up to date. Often it makes fun to develop new stuff, and but the real effort comes later when you must keep the software alive. And in GPU rendering, this is a real problem, because new graphic cards come year after year, new frameworks or major frameworks versions like Vulkan or CUDA, OpenCL or whatever. So doing GPU rendering is a rather large invest if you want to implement anything from yourself, and you won't do this if you feel that your code base does not fit it very well. And this was the case in JWildfire's code base. So it was not really a way to implement it in JWildfire directly, but finally we got the opportunity to use an external GPU renderer, an open source version of the Fractal Architect rendering engine, or in short, FA render. But even if this worked, it's a completely separate tool and cannot be integrated very well. It also suffers from the problem with updating frameworks. In fact, currently it came to an end, both from Fractal Architect side which is discontinued, and from my own. The external GPU renderer, FA render, is very limited. Runs only with CUDA capable devices, and only with this one framework it was always a pain to get the developer tools to work, each version. So finally it came to an end. And another problem of the external FA render was that it does not support all features of JWildfire, and sometimes produce different results, even if it should not. So when we think about GPU rendering for fractals, the only satisfying answer is to implement GPU rendering from start and to use only GPU rendering, so that there are no differences, and there's you must not think about which renderer you use when or where and such things. Always confusion when you have multiple renderers. So true GPU rendering is one of the main goals of JWildfireSwan. And this is important because GPU rendering makes such a great difference that it justifies the effort to even to create a new software generation. With GPU rendering at its heart, we can now think about much more about fluid editing and even fractal animations in real time. We will see this later. Talking about animations, to generate them without GPU rendering is really an annoying, some may say painful task, because the rendering all of the frames take a lot of time, and often you'll see that the animation was not made right, and you see that only after you generate it. So you will re-render all the frames multiple times until it's right. And without GPU rendering, this takes a lot of time and effort. And when you have GPU rendering, this changes in a very drastic way. Of course, it still takes time and effort, but it's really game-changing. Another really important feature about GPU rendering is that it lets your computer remain responsive. Here I mean micro freezes or even longer freezes. When I remember, there were versions of JWildfire where you could not even move the mouse while rendering, because JWildfire occupied any available CPU resource. On the other side, when using the Swan rendering engine, your device stays completely responsive, which is also an important fact when thinking about editing. Another issue with JWildfire was always render quality, even if this is a really large problem in the latest versions. But a clear goal of Swan is also to create nicer images with more fractal details in less time than with JWildfire. And finally, another more development-related thing is that JWildfire is written in a Java programming language, which has many advantages. For example, it runs on any major platform. There's a large community you get always help when you have a question about Java. And there are really good development tools. But Java is not really well suited to create desktop applications, at least not today, where it introduces many restrictions. And many people just say that the user interface is ugly or looks outdated. In general, Java feels very heavy, and I was wishing for technology which makes, again, development more easy and fun and allows to create a more beautiful user interface. So I was looking for a modern platform which has not these problems, and my final choice has become Godot engine. It features a Python-like programming language, which is really fast and fun to use. In terms of development, fast and fun, I mean. And it also creates applications which run on any major platforms. You can even create applications for mobile devices or special devices like Steam Deck. Maybe we will see a special version of JWildfire Swan on Steam Deck one day. And it offers a nice abstraction layer to implement GPU rendering. Using Godot engine, you have not to deal with version numbers of frameworks or frameworks for your graphic cards, because the engine managed this for you. And as a developer and artist, you can concentrate on the problems you want to solve. So in fact, I really, really love Godot engine and would strongly recommend it. I said final point was Godot engine, but there is another point which is important to Swan. This is the final point. I wanted to make fractal art more accessible. JWildfire has really lots of features and windows and menus and tabs and buttons and tables on the windows and menus grown over the years. There's really a lot into it, and even I can't remember all of them. In Swan, I wanted a more minimalistic user interface, which is still very powerful, but not overloaded with features, especially with features which are rarely used. So there will be some missing features in Swan, but this often is by design. So we will have a closer look at the user interface in one of the next videos. In this video, I only want to give you an overview. So finally, in general, one could say, while JWildfire was focused on creating single fractal images and implementing as much features as possible, some of them not very useful, Swan, on the other side, is designed with animation and GPU rendering and simplicity and beauty in mind. Therefore, I chose the subtitle Strong and Beautiful. You will read it in some places. JWildfireSwan, Strong and Beautiful. So, this was really a lot of an introduction. So let's start the actual video and dive into the software.